Hi, everybody. So today's note is about the properties of vectors. So this note doesn't really introduce anything groundbreaking. It just allows us to go through some properties that are true so that later on when we're working with vectors, we kind of know what we're allowed to do and what we're not allowed to do. Later on when we do the dot product, which is kind of like multiplying vectors together, and the cross product, you'll find that some of those intuitive properties are not true. So it's important that early on in our vector work we do identify what properties are true so that we know what we're allowed to do when working with them. Okay, so for example, the commutative property of addition. So this basically just means that you can add in whatever order you want to. So if you have A plus B, you could also just add B plus A, and it's the same thing. So if you're looking at a numeric example, that would be something like 2 plus 3 is the same thing as 3 plus 2. Or an algebraic example might be that 3x minus 5y could also be rewritten as 5y plus 3x. Okay, doesn't matter the order. So being able to switch is helpful with proofs and other problems. So let's show graphically with our understanding of vectors why this is actually true. So in this diagram, AB is vector A, but notice that DC could also be represented as vector A. AD is identified as vector B, but BC could also be identified as vector B. They're equal vectors. Okay, so then AC can be written as two different vectors. So AC can be written as the sum of AD plus DC. So using that triangle. So that would be putting B plus A. But AC could also be rewritten as AB plus AC. So I could also say it's AB plus BC using that triangle, and that direction would be A plus B. So because AC is the same vector, this concludes that B plus A is the same thing as A plus B. So a simple visual example of that. Now we move on to associative property. So this is just if you add these vectors first and then add C, that's the same thing as if you added A with whatever the sum of these two vectors were. So again, we can do this with a diagram. So label P, Q, R, S, and then label PQ as vector A, QR as vector B, and RS as vector C. So notice that if we take A plus B first, okay, A plus B gets us PR. Okay, so A plus B first plus C gives us PR plus RS, which gives us the resultant PS. Okay, but notice that if we look at what vector B plus C is, that is, so if we do B plus C, we get the resultant QS. So if we do A, vector A plus then vector B plus C, that's like saying PQ plus QS, which also gets us PS. So since these result in the same vector, we can say that the associative property is true. Now let's move on to the distributive property of addition. So this just says if you have a scalar, so this is K as in a set of all real numbers, outside of, in brackets, the addition of two vectors, you can distribute that scalar to each vector individually. So again, we can show a numeric example, which would be something like if you have two bracket 1 plus 3. You can change this into 2 times 1 plus 2 times 3. Algebraic example could be something like 2 times length plus width is the same as 2 length plus 2 width. So here's a vector example. So say we have this A and this B. So then that means that this is actually A plus B, or B plus A, but we already showed commutative. Okay, so then here, this vector B has been multiplied by a scalar K, and then we're saying that this vector has been multiplied by the same scalar K. Okay, and because that means these must be similar triangles, then this has to be KA, sorry. So just by looking at this addition, I mean, this is KA plus KB. But now these two have to be in the same ratio because these two triangles are similar. So since ABC is similar to DEF, K times A plus B is equal to KA plus KB. That one's not as pretty as a demonstration, but hopefully that made sense to you if you understand similar triangles. Okay, I'm just going to add 3 more onto here that we're not going to illustrate, but these are good properties to know. So if you add a 0 vector, then you just get your same vector, okay? Notice that you can never add a scalar to a vector. That doesn't make sense. You couldn't have A plus just the number 3, or you can't have A plus just the number 0. It has to be the 0 vector, but then you just have your original vector. Okay, as well, if you have scalars out here, they can be combined in any way. And if you have scalars being added, then they are distributed as you would expect they would be. Okay, here are just 2 simple examples to show these properties in action, and I'm just going to name what each property is as I apply it. This might seem onerous to you or kind of tedious, but it's just to help us remember which law is which property is which. So first, I'm going to distribute the 3. So I want you to think of, while I'm doing this, and as you're writing it down, which of the laws am I actually completing right now? Okay, so that is actually the distributive. Property of addition. Okay, so now we're going to put like terms next to each other. So again, we haven't done this for a while. Probably, you're just used to collecting like terms, but technically you put like terms next to each other first. So this is the commutative property because we are moving them around in whatever order we want to. So we are commuting them around. It's like they're commuting to work. Okay, now this is kind of a weird one to understand, but technically when we collect like terms, we're technically collecting really the coefficients or the scalars. So we don't usually write it like this, but really this is what's going on. So this is the distributive property of scalars. Okay, and then you just get your 5a, b goes away because it comes up with 0 vector, plus 5c. All right. Okay, this last one is saying just if x is this vector, y can be replaced with this vector, and z can be replaced with this vector, determine each of the following. This is pretty straightforward, guys. You just sub in what each one is and collect like terms. So I'm going to ask you to do that, and I'm just going to give you the answers. You should be able to figure this one out. Okay, so yeah. 4k. For B, you get 3i minus 5j plus 6k. And for C, you get minus 9 vector j plus 23. Okay, all right. If you have any trouble with these and coming up with those answers, just let me know. All right, guys, thanks for watching. Hope you learned lots.